Hello, this is Mrs. Sargent, and this is lesson 5.4, molar mass, and converting mass and moles. So if you wanted to buy 10 million gumballs, how would you go about counting out 10 million gumballs? Would you count them out one by one? Probably not. That would take a really long time. You could group them together, and that would help it go a little bit faster, but you'd still have to count them all. Well, another option is that you could take the mass of one gumball and then mass a group of gumballs and divide that mass by the one to get an approximate number of how many you have. And this kind of relates to what molar mass is. Okay, so think about it. If you have 1 dozen apples, so you have 12 apples, and 1 dozen watermelons, 12 watermelons, which has more mass? Well, the watermelons do, because each watermelon in and of itself has more mass. So now think about a mole of copper, and a mole of aluminum. Well, if we look at the average atomic mass on the periodic table, copper is 63.55 and aluminum is 26.98. So if I have a mole of it, if I have 6.02 times 10 to the 23rd atoms, I'm going to say that because each one is, that this is going to be more mass because of the average atomic masses. Okay, so look up carbon's average atomic mass. It's 12.01. And remember that we label our average atomic mass with AMU. Chlorine is 35.45. And iron is 55.85 AMU. Okay, so those are the average atomic mass. Well, here is the mass of 1 mole. 12.01 grams per mole for carbon, 35.45 grams per mole for chlorine, and for iron, 55.85. So how are average atomic mass and the mass of 1 mole of an element similar? Well, they have the same number, but different units. And this 12.01 grams per mole, we can write this 12.01 grams over 1 mole. And this way we can use it as a conversion factor. So molar mass is the mass of 1 mole of a given substance. And remember that 1 mole is 6.02 times 10 to the 23rd particles. And depending on if we have atoms, molecules, or formula units, depends on what those particles are. So how do we calculate molar mass? We have 4 steps that are going to help us with this. The first is that we are going to look up masses of elements on the periodic table, the average atomic mass. Okay. The second step is we're going to multiply each element by the number of atoms. The third step, we're going to add them up. And then the fourth step, label grams per mole, G/mol. Okay, so let's take a look at water. The first thing that we need to do is we need to look up the average atomic mass for each element. Well, hydrogen is 1.01 and oxygen is 16. We have 2 hydrogen and 1 oxygen. So this is going to give us 2.02. And this is going to give us 16 for a molar mass of 18.02 grams per mole. C6H12O6. So we have carbon, hydrogen, and oxygen. Carbon is 12.01. Hydrogen 1.01. And oxygen is 16. We have 6 carbon, 12 hydrogen, and 6 oxygen. So this is going to give us 12.12 96 and 12.01 times 6 is going to give us 72.06. And then if we add these together, we're going to get 180.18 grams per mole. Barium nitrate. The thing we need to remember here is that this 2 is distributed in. So we have barium, nitrogen, and oxygen. Barium is 137.33. Nitrogen is 14.01. And oxygen is 16. We have 1 barium. We have 2 nitrogen. And we have 6 oxygen. So this is for an average atomic mass of 261.33 grams per mole. So in each of these substances, we have 1 mole. In each of these, there is also 6.02 times 10 to the 23rd particles. So, taking mass to moles, we have 5.3 moles of carbon dioxide. We want the mass. Anytime you see asking for the mass or you are given mass, you have to find the molar mass. So carbon dioxide is CO2. We have 12.01 and 16. This is times 2 times 1. For 44.01 grams per mole. Okay, so we're going to start with the 5.3 moles of CO2. And remember, we can write this as our conversion factor of 44.01 grams per mole. Oh, sorry, I meant to write the same thing there. Grams over 1 mole. These are equal to each other, so I can flip it either way. Well, I have moles on the top here, so I want moles on the bottom here, so I don't need to do anything to it. And this is 44. So moles of CO2 are going to cancel. We're going to take 5.3 times 44.01, and you should get 233.25 grams of CO2. Okay. And then our last example problem says that we have 174.5 grams of copper 2 chloride, and we want to know how many moles that is. So remember, we gotta still write our formulas. Copper, this is telling us that this is a 2 plus. Chlorine is a 1 minus. So our formula is going to be CuCl2. Okay. We have mass, so we need to find our molar mass. this will give us 70.90, and add those together, you should get 134.45 grams per mole. Okay, so we're going to start with the mass that we're given, 174.5 grams of CuCl2. And then we're going to take our 134.45 grams of copper chloride are going to cancel. We're going to take 174.5 times 1 divided by 134.45, and that is going to give us 1.30 moles of copper chloride. Okay. So that's it for practice problems or example problems. You have practice in your packet. Go ahead and take a look at it. For number 5, you are going to want to convert all of those to moles. And then when it has you calculate the molar mass to start with, you're going to use that molar mass in problems 1 through 4. Stop by if you have any questions. Thank you. Have a great day.